Behind every breakthrough is a simple idea, and artificial intelligence for risk management reveals the ones that matter. We will focus on what it says about risk and data. Stay with me, the best part is near the end. Chapter 1: Book and Risk. Introduction. Target audience. What you can get from this book? What this book covers. This book's mind map organization of chapters: Introduction to Artificial Intelligence, AI. Introduction to Risk. Introduction to the AI knowledge-based business use cases, AI solutions for risk. Conclusion. References. Chapter outline. Book introduction. Organization of the book. Chapter introduction. Key learning points. Learn and understand. Introduction. Target audience. This book mainly focuses on artificial intelligence, AI, and how managers can apply AI to risk management. This book follows current trends in AI in the branch of natural language processing, natural language question and answering system of AI, conversational AI in risk domains, AI supporting drones, AI cybersecurity, Internet of Things, IoT, devices, and use cases. Each applicable AI topic targets corporate top executives, founders, chief technology officers, chief information officers, chief data officers, chief security officers, chief risk officers, data scientists, data architects, AI designers, AI engineers, project managers, and consultants to understand how to manage risk using AI. Students, teachers, and developers will find this book useful and practical. It will provide an overview of many AI components and introduce how it can be used in corporate environments, startups, large, medium, and small-sized companies. Anybody who strives to understand how AI can be used for risk. What can you get from this book? Understand and learn about AI and how to apply AI to risk. Design and apply knowledge-based AI solutions to solve risk-related problems. Architecting and designing AI-applied systems that mostly rely on the following subject matter experts. Those with a practical view of how solutions can be used, not just developed. Here, Risk provides an example using case studies in the book. Appropriate applied mathematics and algorithms are used in the book. Do not skip the mathematical equations if you have the need to study them. It is important to note that AI relies heavily on mathematics. Applied physics and usage into hardware systems and futuristic approaches from quantum computers to parallel processing of networks in quantum computer handlings. AI is still evolving with many new areas of possible opportunities. Give your full attention to new concepts and applied creative ideas in the futuristic AI chapter. Decision theory, decision-making process, the Markov decision process algorithm. What this book covers. This book covers mainly an introduction to AI and how it is applied in corporations, startups, large, medium, and small-sized companies to help automate the tedious jobs of mitigating risk. This book will help those in organizations' working environment as a resource, applying and automating AI and ML to help human experts. How to get true value from AI. What are the visionary business use cases for AI? How do I identify the best business case to adopt AI and evaluate opportunities? Should I build or buy an AI platform? How do I find and recruit top AI talent for my enterprise? How will I bring AI into my business to increase revenue or decrease costs? How can I facilitate AI adoption in my organization? Especially when dealing with data that include data collection, data preparation, data transformation, securing the data, using the data to align organizational AI, use cases, and much more. provides a mind map to give the reader an idea of what is covered in this book and the organization of the chapters. Mind map of the book. Mind map of Artificial Intelligence Solutions for Risk provides a mind map of AI solutions for risk. This figures gives the reader a sense of which risk areas are covered with AI solutions in this book. Chapter 2: Data and Learning. Introduction to Artificial Intelligence. Introduction to Artificial Intelligence, AI. Types of AI and Purpose. Chapter outline. Define intelligence. Define AI. Types of AI. Purpose of AI. Human senses. Define an AI project. Key learning points. Learn and understand machine learning. Introduction to Artificial Intelligence, AI. What is intelligence? Intelligence is the ability to understand or deduce information and retain it as knowledge, and subsequently apply it toward a context in an environment. Barat 2013. This includes logic, self-awareness, learning, emotional knowledge, reasoning, planning, creativity, and problem-solving. Intelligence can be found in humans and animals. This intelligence is expected to extend to machines, and that is what strong artificial intelligence, AI, is about. This book expands from basic to advanced AI. What is AI? People all over the world provide definitions of AI. Here are some definitions of AI. AI is the science and engineering enabling intelligence, specifically in computer programs, using computers to understand human intelligence and other living things. About 60 years ago, John McCarthy called on a group of computer scientists to discern if computers could learn like a child. McCarthy 1959. The project objective was to see if computers could solve all sorts of problems that are reserved for humans and to improve themselves, especially when addressing a huge amount of data. Since then, AI has been in university laboratories and super-secret labs. In 1955, McCarthy defined AI as having 7 characteristics, simulating higher functions of the human brain. Programming a computer to use general language. Arranging hypothetical neurons in a manner so it can form concepts. Finding ways to determine and measure problem complexity. Self-improvement. Abstraction that defines the quality of addressing ideas rather than events. Randomness and creativity. McCarthy further discussed that all the various parts of learning and intelligence can be precisely described as intelligence that a machine can be built to simulate. In 1995, Jake Copeland described AI further, averring that AI has no technical concepts. He analyzed what those working in AI must achieve before claiming to have built a thinking machine. Copeland further itemized areas in AI as follows. Generalized learning. Recognize human faces. Reason to draw conclusions based on information gathered. Problem solving. Give way to humans. Other people defined AI as computers that seem like they have human intelligence. Not merely the ability to obey road signs and drive forward, rather to show human emotions such as road rage. This is not a new concept. One can recall Dortmund Professor McCarthy, who coined the term AI in 1956. Recently, a huge amount of data is being generated. Technology giants such as Google, Facebook, Twitter, Microsoft, Amazon, and IBM embrace AI to solve problems of various magnitudes. AI is being used in robotics to solve complex empirical problems. AI can manifest in many ways, such as forecasting the weather, based on the data from its source. However, the same data can yield a different forecast, based on the intent of the question. Thus, it is capable of thinking, based on how it is programmed. NLP makes this more exotic. One of the most exciting areas of AI is machine learning, ML. Machines can retain knowledge based on the data collected, in contrast to a human who retain knowledge and respond differently. Types of AI. There are 3 types of AI: weak, strong, and superintelligence. AI researcher Ben Goertzel, 2014. Weak AI focuses on narrow tasks. Strong AI can apply intelligence to solve problems generally rather than focusing on one specific problem. AI has the intelligence to respond with intelligence and can be compared to a typical human. Superintelligence AI is supposed to have intelligence attributes that surpass those of the brightest and most gifted human minds. Muehlhauser, May 2014. Its recursive self-improvement provides a rapid outcome able to create artificial general intelligence. AI and capabilities. The field of AI is vast and yet recognizes many unknowns. Some known AI capabilities are listed as follows. Brownlee, 2013. NLP enables machines to communicate in natural way in human languages. Knowledge representation enables machines to represent known knowledge. Automated reasoning enables machines to determine appropriate reasoning like a human. ML entails teaching the machines. Computer vision enables machines to see and detect. Robotics helps in automating movable use cases such as manufacturing units. Internet of Things, IoT, devices help in data collection and controlling machines through sensors. Virtual reality helps in simulating human senses close to reality. Make your mind believe. What is the purpose of AI? To better humankind. To help humans extend their capabilities on repeated tasks through automation. To avoid human and manual errors on repeated tasks. To improve programmatic approaches to align with ever-changing business demands and requirements. Instead of programmatically maintaining business rules to data-driven decision processes, accommodates business demands immediately. To handle the large volume of data generated every day, using approximately billion gigabytes. To handle a variety of data in an automated way. To handle the velocity of data. To detect patterns in data. No human or group of humans can handle the huge volume of data and the variety of data at its present velocity of accumulation. Human senses. The 5 senses of humans are sight, sound, touch, smell, and taste. Currently, machines are capable of replicating the sight sense through a camera to see and project through monitors and projectors. Machines can replicate the sound sense through a microphone to listen. Speakers speak through speakers, users touch screens, keyboards, and mouse. People have yet to develop machines that have a sense of smell and taste. However, a couple of new inventions are being developed, such as a digital nose and smell maker, as well as an electronic tongue to mimic the taste sense. People are working to answer the challenges associated with new technological machine and device capabilities. Artifacts are still evolving, and reliability and usability are not tested yet on real-world applications. Acceptance among users is still unclear. Applying machines with these digital senses to real-world applications is an enormous accomplishment, although they are still in the research and development (R&D) experimental phase. These kinds of risks are very high, and one corporation alone cannot handle these challenges. That is why many developers are using open-source environments and conducting university-based projects. It is unclear how reliable and secure capabilities will be to avoid early detection in the new evolving technologies. The horizontal and vertical AI landscapes. Horizontal AI focuses on general questions and fundamental problems across industries. Large corporations such as Google, Facebook, Microsoft, Amazon, IBM, and universities are investing in horizontal AI. Vertical AI focuses on a specific industry problem, specific business case, and use cases. Many startups and medium-sized companies are investing in and exploring vertical AI. Some major horizontal AI projects are Watson, IBM, AlphaGo, Google, Google Brain, Blue Brain, IBM, Facebook, Siri, Apple, Google Now, Cortana, Microsoft, Wolfram Alpha, Wolfram Research, Echo, Amazon, and Google Home. Some of the vertical AI projects are www.BizStats, AI Retail E-commerce and Event Ticket. Here is the list of supported industry-specific verticals. Retail E-commerce Analytics AI, https://BizStats. AI/solutions/by_industry/retail_e-commerce. HTML Automotive Analytics AI, https://BizStats. AI/solutions/by_industry/automotive. HTML Banking and Financing Analytics AI, https://BizStats. AI/solutions/by_industry/banking_finance. HTML Consumer Products Analytics AI, https://BizStats. AI/solutions/by_industry/consumer_products. HTML Define AI projects. An AI project is similar to PMBOK, PMI 2017, project definition, except that AI projects are more dependent on data and algorithms, such as the availability of initial data for training, continuing data collection strategy, cleaning up collected data, determining the useful features of data, transforming data to fit a model, selecting appropriate algorithms, evaluating multiple algorithms to determine accuracy, comparing against other algorithms, and determining the learning rate of the model. Can this model function autonomously, or does it need human intelligence to speed up the learning process? The first phase of an AI project is the most important. It defines and identifies business cases and use cases like a regular project, but has more risk associated with it. Because AI projects are still in the discovery mode and processes are still evolving, companies are trying to learn from each other's mistakes, challenges, and new knowledge, determining how to monetize. Again, this falls into the business value proposition like a regular project. AI project value proposition. AI project value propositions include great business value, causing an abrupt increase in revenue in the shortest time possible by gaining more customers to increase market share, in the mode of startup companies. AI projects are continuous, collecting a new set of data and applying predefined/pre-selected algorithms and pre-trained models that have already gone through the initial training. The goal is to reach success with great accuracy, near to 80% or more. The required accuracy is based on the business case, the goal of the project, and the problem. For example, the AI self-driving car project needs nearer to 100% accuracy and has zero fault tolerance. This is because human safety is directly involved. But some other AI projects, such as assistance provided by Apple's Siri project, may not need 100% accuracy. In general, more accuracy with less fault tolerance is better. AI projects need the latest trends and demanding roles, skill sets such as those of data scientists, data architects, data designers, data engineers, ML engineers, AI engineers, cloud engineers, and subject matter experts in their respective fields. In addition to human resources, Machines are also part of the resources needed, such as IoT devices, virtual reality devices, robots, and others. For AI-based projects and AI products that enable business value creation, using AI will provide more value that is data-driven and automated. Business value versus time. Business value is the net quantifiable benefit that may be tangible, intangible, or both. Business value benefits can include time, money, goods, or intangibles. Most corporations strive for the following business value: how to safeguard and increase monetary assets, how to increase market share and revenue share, how to increase the customer base by designing innovative, useful products, how to increase the goodwill of the organization, how to improve brand recognition, brand value, and corporate reputation, how to improve customer experience. Big data ecosystem. The big data ecosystem is growing exponentially, meaning more data are being generated every minute, and usage of data devices, data collectors, data aggregators, and data users or buyers is increasing. In the big data ecosystem, a need exists for AI solutions for risk. The risk associated with AI projects is enormous. AI projects have positive risks and negative risks. The next section details some positive and negative risks of AI projects. Big data ecosystem. Positive and negative risks of AI. One major challenge and a negative risk of AI is to align with human emotions and safety. It is presumed that AI is programmed to do something that is overwhelming. If AI gets into the hands of the wrong person, it can be used to create harm, such as serving as a weapon. AI arms can lead to AI war, which may cause mass casualties. Weapons could be designed to be extremely difficult to turn off, causing humans to lose control of the situation. Eliezer Yudkowsky, 2008. Humans may have only good intentions when developing AI systems, but the system itself may develop a destructive method to achieve its intended goal. In such a situation, much havoc can ensue. For example, requesting a vehicle to take a person from point A to point B very fast might create problems because an AI machine may travel too fast. Many other examples can be added to this scenario. The point here is that AI systems must be made with considerations for human safety. Well-known people in science and technology have expressed concerns about AI: Stephen Hawking, Elon Musk, Steve Wozniak, and Bill Gates. Initially, strong AI may take a long time to develop, but recent accomplishments with AI has provided concern that the acceleration of AI development can move at a surprising pace if humans do not take the necessary precautions to protect the development of strong AI. AI can become more intelligent than any human, and ultimately humans cannot predict how it will behave. Presently, humans control the world, and to have something else controlling the world is a scary thought. Thus, the idea is to support AI safety and with great caution. Negative risks of AI. No standardized terminology exists, and AI can loosely be viewed as a machine that chooses whatever action appears to best achieve its goals. This means AI can choose whatever function it assesses as best, depending on the mathematical algorithm. The goal of the AI system may not be intelligent enough to think of resisting programmer attempts to modify it, and may not be sufficiently advanced to react rationally. This lack of oversight may lead to resisting any changes to its goal structure. A superintelligent program created by humans may be obedient to humans. However, it may be more intelligent than a human, thereby understanding the moral truth of humans more than humans. This could create a problem slowing it down, simply because it knows more than the human, and may think it knows the best approach. Using AI to do things for humans may lead to losing our skills. Humans will end up blaming machines for a mistake made by humans. A smart machine may decide that humans are not needed. AI may use human weaknesses against us. AI may use human intentions against humans. Positive risks of AI can now automate everyday tasks. AI can help with management decisions and put the most effective teams together. AI can process and analyze a huge amount of data. AI can converse with customers to resolve customer issues. AI can create algorithms to forecast growth. AI can help doctors diagnose patients. Incorporating AI into an organization is like having a private robotic assistant that can streamline the work that needs to be undertaken in the office space. AI can be quite productive. AI can carry out menial tasks in the office such as managing referrals. AI can update and coordinate schedules. Some predictors speculate that AI is not yet mature enough to provide careful assessment of its value to the organization. Planning for the inclusion of AI into organizational capabilities can be handled in an orderly and beneficial fashion with a little planning effort. AI technology is changing at a fast rate. Organizations are now in various stages of managing their AI interests. Challenges of AI and adoption. Distraction of AI. Many organizations are distracted by the following issues attributed to AI. Organizations are concerned that not enough attention is being focused on the dangers of AI. The fact that many devices are being hooked to the internet, it is creating fear that the data generated from the devices may cause problems in terms of cybersecurity issues. Besides, there are not enough skilled cyber workers. It is being predicted that using AI and ML could automate threat detection and response. There is a possibility that this approach could be the response to a potential threat and likely be more efficient. Ford, February 11, 2015. Many organizations are suspicious of data risk issues. However, ML algorithms could create a false sense of security. Quite recently, researchers have trained supervised ML software. Algorithms to train the machine learner must be well defined. Rolled out software requires thorough scrubbing of anomalous data points. The algorithm may miss some attacks. Attackers who get access to corporate systems could corrupt data by switching labels so that some malware is tagged as clean code. Algorithms that are compromised and do not flag a problem can cause bigger risk issues. In addition to all the risk issues discussed, AI and ML should not be used for risk defense. An appropriate risk process must be in place to monitor and minimize the risk associated with algorithm adoption and ML. Researchers showed that a challenge persists in finding resources with knowledge and experience in cybersecurity and data. Mass unemployment due to AI adoption. It is typical in the United States that people stop working at the age of 65 and spend their time mentoring other workers or volunteering. In the manufacturing sector, AI may not have a negative impact on losses. Job losses may come in the service sectors, such as construction, healthcare, and business. The loss of a job will mostly depend on how jobs will be transformed by adding new tasks while being supported by computers and robots. AI algorithms are replacing jobs that are routine, repetitive, and take much time and thus are more easily and effectively performed by machines and robots. This means humans can be left to tackle interpersonal, social, and emotional jobs. Furman, December 20, 2016. A typical example is that the bank teller job may change so tellers will concentrate on giving money and helping clients. Areas in which AI and ML can be greatly helpful are agriculture, weather forecasting, and determining the latest market prices. A typical requirement for an online customer is requesting help to purchase products. AI can add services to improve customer experiences, allowing companies to retain those customers. It is possible that human labor may be less expensive than machines. There may be a lack of required skill, poor energy infrastructure, broadband, and transport networks. Other areas such as legal and regulatory issues could use AI quite well. When AI is deployed, the doctor needs to confirm if the AI is responsible for claims of medical malpractice. The impossibility of total human control AI is currently popular and can be heard everywhere. Many business sectors use AI, including insurance, healthcare, genetics, agriculture industry, road traffic management, and other areas that are based on data. Some people believe companies are trying to remove human resources from routine work and replace them with AI and ML. Many organizations like what AI can do for them. Yet, other companies focus on negative aspects such as data risk issues, data privacy concerns, mass unemployment due to AI integration, unbiasedness of AI, the impossibility of total human control, and the notion that AI-based solutions are still too expensive for most organizations. There is a question of whether real problems exist in using AI or simply being prejudiced against the application and idea that it brings to the business market. AI has been used and recommended by many experts in business and computing fields. AI and ML use large amounts of data. Most of these data are personal. Recently, data have leaked from organizations such as Facebook and Apple. These organizations use ML for personal data processing. Is it possible that AI and ML will increase the probability of data leakage? However, no cases have occurred of AI data leak. Organizations build AI to solve data leak problems. Usually, top-notch designers design AI software, making the application safe and difficult to hack. If the software were hacked, it would be difficult to understand and make changes to it. The data in AI or neural networks cannot be decrypted because of the way they are built. Subsequently, AI systems and neural network systems are developed using open-source frameworks and libraries such as Microsoft CNTK, Theano, TensorFlow, Caffe, Keras, and Torch. Most of these open-source frameworks are supported by large organizations such as Google, Facebook, and Microsoft. The supporting organizations have policies that ensure privacy through penetration tests. Of the 5 causes of data breach, 4 come from a human error that stems from password error. This means that problems related to AI are not legitimate concerns and can be considered myths. Data leaks will diminish drastically if organizations pay more attention to train their staff with the basic rules of data management. People do not like their data to be analyzed in fear of being targeted. Personal data analyses have been performed in insurance, finance, and other industries. People fear that other people or machines will know their private details, which creates fear in them. AI alone does not violate any personal data policies. However, data insights reveal organization status to show profit or loss. Organizations developing AI have processes to regulate documentation and personal data. Further, people fear that AI and the neural network will replace managers in making decisions. Every organization is interested in skillful and loyal personnel. The existence of AI and neural networks does not mean companies have plans to substitute humans with computers, even though computers can do the work of the human faster and probably better. Gartner predicted that, in 2020, AI will generate million jobs from million jobs. AI programs and robots are liable to make mistakes. A good example can be cited with a case of robot failing exam questions that would be obvious to young children. Police departments have used AI systems, and those systems can also make mistakes. This can be concerning, such as distinguishing between a toy gun and a real gun. People have some level of fear that a smart computer with AI will control humans instead of the other way around. This belief stems mostly from customers who think about dealing with computers rather than humans after watching sci-fi movies. This further raises the following questions. Complex AI systems comprise a few subsystems such as speech recognition, decision-making, and data analysis. All the subsystems are hard-coded, thus, it is not possible for the subsystems to add new features by themselves. AI systems have limitations based on how they are developed. Developing AI that is close to a human can be quite expensive to have and maintain. Developers can create very complex neural networks and ML algorithms for various industries. However, the cost of such systems is high and difficult. Complexity grows with new product ideas. Data to AI. Let us illustrate how AI operates. AI starts with data and progresses to data science, then to ML, deep learning, and finally to AI. The relationship between data, data science, ML, deep learning, and AI. The distinction between data, data science, ML, deep learning, and AI is defined next. Data to AI. What are data? Data are information usually used for analysis, calculation, or to plan something. Data are often produced or stored by a computer. Data have value and relate to subjects that are qualitative or quantitative. Data explore the study and construction of algorithms that can learn from data and make decisions and predictions or decisions by building a model. ML is a subset of AI in the field of computer science and data science. Examples of data in the corporate world are revenue, sales data, profits, and stock prices. In the government sector, examples are rates such as crime rates and unemployment rates. Examples in the non-governmental sector are the number of homeless people or the top location of homeless people. What is data science? Data science is the field that uses scientific methods, processes, algorithms, and systems to derive knowledge and insights from acquired data in an environment. Data can be structured or unstructured. The idea of data science is to unify statistics, data analysis, ML, and related methods to provide insights. What is ML? ML was first coined by Arthur Samuel in 1959. ML explores the study and construction of algorithms that can learn from data and make decisions and predictions by building a model. ML is a subset of AI in the field of computer science and data science. ML is used in a range of computing tasks that require designing and programming explicit algorithms. ML means simply teach machines to accomplish expected tasks. Major problems of teaching machines. Major problems in teaching machines are identifying methods to teach the machines, identifying, collecting, and preparing training data. It takes much time to train machines. Training machines needs many computational resources. ML requires improving model accuracy with efficient time and optimal resources. Types of ML systems. The types of ML systems are very important to choose, based on the use cases, type of available algorithms, types of data, and problem one is trying to solve. Listed as follows are the most commonly used types of ML systems: supervised ML, unsupervised ML, semi-supervised ML, transfer ML, reinforcement ML, ensemble learning. Additionally, types of ML can be categorized based on how the machine is trained. Training is based on offline learning or online, real-time learning in a predefined batch mode or stream mode with regular intervals. Offline learning, online learning, batch mode learning, stream mode learning. Another way to categorize ML systems is based on similarity and derived from mathematical models. Instance-based learning is how similar the new set of data is coming in and detecting new patterns on data that enable continuous learning. Model-based learning derives from mathematical formulas to construct a mathematical model. What is supervised ML? Supervised ML is a way to teach machines through training data by examples with input and output of historically collected data or valid data labeled by humans. The name supervised ML reflects concept of supervised by humans to improve high accuracy to address problems of classification or categorization. Further, the goal is to predict the future value of continuous variables such as predicting housing prices, based on available historical data by applying appropriate algorithms to extend mathematically and geometrically from the historical data points linearly or nonlinearly. Linear versus nonlinear. Here are explanations of linear and nonlinear data points. This is the starting point for determining a pattern in the data that is either linear or nonlinear. Linear patterns are any data points that are in these patterns: x, y equals 0, 0, 1, 1, 3, 3. Linear and nonlinear graphs. Some of the important and famous supervised machine algorithms are k-nearest neighbors, a non-parametric method used to classify and regress. Linear regression is a linear approach to modeling the relationship between a dependent variable and one or more explanatory independent variables. Logistic regression is a method of analyzing a dataset with one or more independent variables that determine an outcome. Support vector machines are supervised ML algorithms used for classification or regression challenges. Decision trees and random forests are collections of decision trees whose results are aggregated into one result. Neural networks are a series of algorithms that recognize underlying relationships in a set of data through a process that imitates the way the human brain operates. Some typical use cases for supervised ML algorithms follow: classification of customers based on purchasing patterns, behavior patterns, frequency patterns, income-based patterns, and so on. Grouping of customers by lifetime value, usage patterns. Predicting customer churn based on usage pattern, value versus price, competitor pricing strategy on campaigns, introducing new products and services, and much more. Fraud detection by analyzing data to find anomalies, unique patterns, and extreme cases. Sales forecasts and predictions. Risk identification and risk categorization. Building and categorizing threat models. What is unsupervised ML? Unsupervised ML describes a type of teaching machine through training data autonomously without labeled data. The name unsupervised ML reflects the concept of being unsupervised by humans by extending algorithms to approximate groupings, identifying the association between data and anomaly detection. Some important and famous unsupervised machine algorithms are clustering association rule, anomaly detection, dimensionality reduction. Some of typical use cases for unsupervised ML algorithms are clustering or grouping of any data, anomaly detection of any set of data, similar product and associated product recommendation, feature reduction on high-dimensional data. What is semi-supervised ML? Semi-supervised ML is a type of ML with some part using a supervised learning method and some part using an unsupervised learning method in any combination of labeled and unlabeled data. Typically, semi-supervised ML applies the unsupervised ML algorithm first for unlabeled data and identifies labeled data and applies supervised learning algorithms to improve accuracy. Sometimes, annotation tools are also used to complete human labeling through web-based applications such as http://bizstats, AI/product/URI, HTML bizstats, AI URI annotation tool, bizstats, AI event tickets application programming interface, API, improves user's search experience by a named entity recognition ML model, exclusively for event ticketing sites. What is deep learning? Deep learning is part of ML methods based on useful data representations or features from the raw data. Data representations are meant to be the understanding of the data structures and identify, extract, and evolve underlying features from the raw data. The feature S learning can be supervised learning, semi-supervised learning, unsupervised learning, or reinforcement learning. Different deep learning architectures are artificial neural networks, deep neural networks, deep belief networks, and recurrent neural networks based on learning data representations. Typical distinctions between traditional ML approaches and deep learning approaches are that deep learning extracts automatic learning features from the raw data using deep learning models formed by different types of layers. Fully connected neural network layers consist of a list of inputs inserted in a list of outputs. There are three basic types of layers: 1. Input layer, 2. Output layer, and 3. Hidden layer. Some functionality-based layers are the convolution layer, max/average pooling layer, dropout layer, nonlinearity layer, and loss function layer. Fully connected neural network layer convolution neural networks convolution neural network, CNN, consists of a convolution layer that filters input section by section for useful features and flows through all sections to automatically extract the important features for the given problem. CNN works best in image recognition use cases. See the following illustration: Perceptron, P2 input layer 1 output layer. The perceptron is the basic architecture of artificial neural networks. Let us consider x1, x2, x3, xn as inputs and w1, w2, w3, wn as weights. Chapter 3, x3, w3. xnwn and weighted sum z equals w1 x1 plus w2 x2 plus w3 x3 plus wn xn equals wt. xh x equals step wt. 10 equals step z feed forward ff2 input layer 2 hidden layer 1 output layer. Radial basis network RBF2 input layer 2 hidden layer output layer. Deep feed forward DFF3 input layer 2 hidden layer 1 output layer. Recurrent neural network RNN3 input layer 2 hidden layer 3 output layer. Long/short-term memory LSTM3 input layer 2 hidden layers with memory cell 3 output layer. Gated recurrent unit GRU3 input layer 2 hidden layers with different memory cell 3 output layer. Autoencoder AE4 input layer 1 hidden layer 4 output layer with a matched number of input cells to output cells. Variational AE VAE4 input layer 1 hidden layer with probabilistic hidden cell 4 output layer with a matched number of inputs to output cells. Denoising AE, DAE 4 input layers with noisy input cell 1 hidden layer 4 output layer with a matched number of inputs to the output cells. Sparse AE, SAE2 input layer 1 hidden layer deep learning has been applied to image recognition, computer vision, speech recognition, natural language processing, machine translations, and much more. Most recently, deep learning has become very popular in the technology industry in the following areas of computer assistance, human language translations, customer support, bots, and much more explored while writing this book. As to AI for risk, we used most deep learning architectures to automatically detect features from raw data to apply respective use cases for risk. These are covered in the AI Solutions for Risk chapters. What is transfer learning? Transfer learning focuses on storing knowledge from solving one problem and applying it to another or similar problems. A typical example is knowledge gained from recognizing one thing and applying it to a similar thing. Transfer learning is a type of transfer knowledge gained through previously trained models and then applying additional training to answer a specific problem as an add-on. The goal is to use a previously trained model for a similar problem and to train the model to extend the solution to other problems. A typical example is in natural language processing applications. Some models were trained with the English language corpus, the knowledge gained from recognizing English words and grammar, and then applying that knowledge to act as a chatbot with additional training towards specific use case-based problems, making it a chatbot. What is reinforcement learning? Reinforced learning is the part of ML that relates to how software agents are supposed to act in some environments to maximize reward. Disadvantages related to reinforced learning usage accrue from its generality. Researchers study this aspect in game theory, control theory, operations research, and statistics. Reinforced learning is different from standard supervised learning in correct input-output pairs. Reinforcement learning consists of a learning agent that continuously learns from observing and trying out the next action, based on the defined policy. The machine earns rewards or penalties and, based on the real-time examples or tryouts, automatically updates policies. The machine continues these steps until the optimal policy is constructed. Markov decision process. How does one apply Markov decision process, MDP, to automate the decision-making process? MDPs comes from the Russian mathematician named Andrew Markov, going back to 1950. MDP provides a mathematical approach for making decisions in situations with output that are partly random and partly under the control of a decision maker. MDP has been used to study optimizing problems using dynamic programming and reinforcement learning. People in many disciplines use MDP such as robotics, automatic control, manufacturing, economics, applying gaming, and driverless cars, and it can be extended to risk use cases. MDP can be better explained using a scenario where the thought process is applied as an agent. In the case of the ML model, the thought process uses a calculation that goes through the trial-and-error process. In summary, MDP is a sequential decision for a fully observable, random environment, MDP. This environment consists of a set of states, a set of actions and rewards, that includes positive and negative rewards. The policy will be captured to maintain different possible states, S0, S1, S2, Sn, all possible actions from the current state to the new state, A, S0, A, S1, A, S2, A, Sn, and respective rewards, which is Rs. The policy is represented as S. MDP is explored in detail in the coming chapters and is illustrated as follows. a probability to move to different states. A way to evaluate rewards to being in different states. S. A set of states, a set of actions. T. S. A. S. A transition function / model / dynamics prob that AA from SS leads to S, that is, P. S. A. S. P. S. A. S. R. S. A. S. R. S. A. S. A reward, cost, function aka R. S. R. S. or R. S. R. S. to maximize the reward / cost. A start state, a discount factor. MDPs are non-deterministic / stochastic search problems. Haskell, May 10, 2019. Non-deterministic means that next action could be anything, in any direction, and not in the predefined sequence of steps. Each time it goes to a different state that is not in sequence, it may not be the same. State transition is represented as an equation. For a Markov state S and successor state S, the state transition probability is defined by PSS equals state plus 1 equals S as state equals S. Two approaches to agent learning are active learning and passive learning. Passive learning mainly focuses on learning the possibility of the environment and exploration, whereas active learning builds policy by acting. Decision toward next action. MDP process use cases mainly rest on the decision to determine the next action for the use cases listed as follows: robot path planning, route planning, aircraft navigation, driverless car navigation, manufacturing process, network switching and routing. Monte Carlo. The Monte Carlo MC algorithm is based on the small probability concept of the randomization algorithm, which applies randomness and applies the statistics of standard normal distribution. It uses repeated random sampling to get approximation solutions. This method is used in a case with no analytical solutions or numerical solutions. Steps to implement MC methods follow. Determine the properties of statistics of input data. Generate all possible inputs based on the identified properties of statistics in Step 1. Perform a deterministic calculation. Analyze statistical results. MC simulation. MC simulation is a computerized mathematical technique to account for risk in the quantitative analysis and decision-making process. An MC simulation is a useful tool to predict future results by calculating a formula multiple times with different random inputs. This method can solve many optimization problems and numerical problems by generating sampling from statistical distribution input data to simulate working systems and predict financial investments with risk analysis to theoretical physics problems. Because the integral part ranges from 0 to infinite, this needs a numerical approximation. Crude MC. This crude method of calculating approximation uses the following formula: determine variance of estimation, determine variance of estimation expanded. Common probability distributions are normal/bell curve, log normal, uniform, triangular. Most business activities, plans, and processes are too complex for an analytical solution. Many business situations involve uncertainty in many dimensions. For example, variable market demand, unknown plans of competitors, uncertainty in costs, and many others. What is MC and how it is used? MC simulation is named after the Monaco gambling spot. The MC technique was originally developed by Stanislaw Ulam, a mathematician who worked on the Manhattan Project when recovering from brain surgery. The technique was developed in collaboration with John von Neumann. Developers use MC simulation to model the probability of different outcomes such as identified risk occurrence. Usually, developers would use MC if the risk cannot be easily predicted. Usually, the difficulty with the prediction may be due to some intervening random variables. Developers use the MC simulation technique to understand the impact of risk and uncertainty in a project risk prediction and forecasting model. The technique has been used in projects, science, engineering, and supply chains. In a project risk analysis that has significant uncertainties, MC might be effective. Usually, in organizational projects, random variables may interfere with the risks, requiring the use of MC. MC tends to have an enormous array of variables that lend themselves to applications. It can be used, for example, to assess the probability of cost overruns in projects. The telecommunication industry has used MC to determine network performance to help optimize the network. The insurance industry and various industry silos have used MC when necessary. Let us demonstrate how the MC technique can be used by projecting a price. Let us use historical price data from a historic asset. Periodic daily return equals ln, day's price previous day's price. Subsequently, we may use the average, STDEV. P and VAR. P functions on the whole resulting series to get the average daily return, standard deviation, and variance inputs, in this order. The next step is drift equals average daily return, variance 2. Instead, drift can be set to 0. This choice reflects a certain theoretical orientation, but the differences are not supposed to be far from each other, at least for shorter time frames. Going forward, get a random input, random value equals standard deviation asterisk normsenv, rand. The equation for the following day's price is next day's price equals today's price asterisk e caret, drift plus random value. Now, use e to a given power x, and then use the exp function, exp, x. The calculation can be repeated the desired number of times. Each repetition will represent 1 day, to obtain a simulation of future price movement. Generating a random number of simulations, it can assess the probability that a risk S price will follow a given trajectory. Q-learning is model-free reinforcement learning and goal to build the policy of the environment. Q provides the quality of action, A, for given state, S. Bellman equation where E refers to expectation and refers to discount factor. Thus, the Q-value equation, optimum Q-value equation. Deep Q network. The Deep Q network is the extension of the Q-learning function to update the Q table. But with so many combinations to create these actions and states, to manage the rewards policy becomes complex, and it is impossible to manage many combinations created in the Q table. So, the Deep Q network is the idea to create a neural network that will be approximate for each state and the different Q values for each action. The logical sequence follows: Q value network state dash Deep Q neural network dash Q value action 1, Q value action 2, Q value action N. Deep reinforcement learning applications are used in the following areas: games Go, poker robotics robot controller computer vision recognition, detection NLP language translation, conversational finance pricing, trading, risk management systems performance optimization. What is classification? Classification is the problem that identifies a set of categories to which new observations belong. One of the most often used ML algorithms uses cases to classify certain differences to differentiate the category by classification. Classification is the process of predicting the class of given data points. These classes are called targets or labels or categories. Classification modeling is the task of approximating a mapping function, f, from input variables, x, to discrete output variables, y. So, y equals f, x. A classification problem is when the output variable is a category, such as a number or letter or disease and no disease. A classification model attempts to draw some conclusion from observed values. Given one or more inputs, a classification model will try to predict the value of one or more outcomes. The several classification models include logistic regression, decision tree, random forest, gradient-boosted tree, multilayer perceptron, one versus rest, and naive Bayes. Two types of learners in classification are lazy learners and eager learners. Lazy learners take less time to train and more time to predicting classification. Examples of lazy learners are k-nearest neighbor and case-based reasoning. Eager learners construct a classification model based on the given training data and coverage to have the entire instance space. Eager learners take more time on training and less time on classifying. Examples of eager learnings are decision tree, naive Bayes, and artificial neural networks. Classification. Decision tree algorithm builds classification or regression models in the form of a tree structure with if-then mutually exclusive rules, and these rules learn sequentially using the training data. This process continues until it meets the termination condition. The problem with the decision tree is that it could easily get into the overfitting problem. That means too many rules were constructed, limiting generalization. Chapter 4: Risk and Risks. Introduction to risk. Definition of risk. Examples. Risk. Business case. Different types of risks. Risk management process. Risk categories. Chapter outline. Define risk and provide examples. Illustrate various risk areas. Illustrate risk process areas in detail. Determine risk mitigations. Illustrate risk standards. Key learning points. Learn and understand risk. Identify risk areas. Mitigate risk. Understand what uncertainties exist. Analyze and determine which events must have a planned response. Adopt an approach for each risk event, defining what triggers a response. Maintain risk plans. Monitor risk occurrences. Definition of risk can be defined as the possibility of gaining, good, or losing, bad, something such as financial benefits, time benefits, brand value, customer value, and any measurable value. Thus, two types of risks are positive and negative. While investing money into a business, financial gain is positive and financial loss is negative. Risk can be the uncertain potential, unpredictable, and uncontrollable outcome. Risk perception can be judgment people make about severity and possibility. Any task or action comes with some sort of risk. Risk is uncertainty. Typical risk is facing an unfortunate situation, such as losing an investment. Another example is that an organization may have a lower than planned and budgeted trend of doing well in the financial calendar year. Technical projects tend to be lean. This means challenges occur due to work with inadequate funding, staff, and equipment. To make matters worse, managers have a persistent expectation to complete projects faster than projected. Some concerns lead to risk and include issues that are not addressed and allowed to persist in the corporate workspace. Some concerns may include issues that affect a project's time, schedule, cost, or quality and scope. Project or task areas that require assessment and executive review. Subsequent areas that do not address cultural or organizational changes, technical changes to applications, legal or contract changes, and the business/project sponsor owner with new requirements. Occasionally, people working on projects for corporations contribute people risks that consist of the following: late start of a project. At times, project personnel are unavailable at project start, perhaps due to finishing previous projects later than expected. Occasionally, Project resources may be lost due to resource resignation, promotion, reassignment, health, or other reasons. Consultants and contract workers may be in short supply or unavailable. The firm may experience a temporary loss of staff due to illness, unusual busy work at the organization site, support priorities, or for other reasons. Queuing could be an issue on projects due to slippage related to experts' commitment availability. Lack of motivation can lead to a lack of team interconnection and interest. This is more likely to happen on long projects. Other types of risks will be described in the examples provided. Another example of a risk is that an organization may have a lower than planned and budgeted trend of doing well in the financial calendar year. Other related topics of risk will be explained in this chapter. Example of a risk: business case. Risks in an organization/business sector can be dangerous and unpredictable for organizations. The following case studies are typical examples that provide clear examples. Case Study 1. Blockbuster and Netflix Purpose. The risk purpose for the Blockbuster and Netflix case illustrates how due diligence is important to commit to business dealings. Being too quick to get into an agreement can create problems for organizations. This means an investigation is required to look at positive and negative risks. Accountability of new trends and impact to large corporations and the risks associated. How do we avoid such new trend changes and impacts to other corporations? How do we detect business model trends early enough to save large corporations? Can we detect new trends to answer this problem? Business case summary. The case study of Netflix. Reed Hastings, founder of Netflix, and Blockbuster. John Antioco, CEO of Blockbuster. In 2000, the founder of Netflix, based in Dallas, proposed a partnership to Blockbuster, which was atop the video rental industry. The proposal was that Netflix could run Blockbuster's brand online and Blockbuster could promote Netflix in its stores. Eventually, Blockbuster went bankrupt in 2010 and Netflix became a $28 billion company. Hastings is widely hailed as a genius and Antioco is considered a fool. Scientists for the past 15 years studied the incident, and now they know how the networks function and how this incident could have been avoided. The lesson of risk stems from the notion that in 2000, Blockbuster had thousands of retail locations and millions of customers with enormous budgets and efficient operations that dominated the competition in this business sector. Unfortunately, Blockbuster had a weakness of charging its customers for late fees. This was an important model that earned them enormous revenue. Netflix did not have the same late fees and did not have locations. Customers could watch videos if they wanted or return them to get another one. However, customer needed to have a subscription to rent videos. This worked well for Netflix. The lesson here was that a risky business model led to the downfall of the Blockbuster Corporation. This is one example of business model risk. Blockbuster did not incorporate a new type of business model and new technological trends. Positive risk was the Netflix approach and negative risk was that Blockbuster had fallen into a trap. Similarly, AI is heading into new technological trends and industrial revolutionary business model transformations. Corporations should embrace this model trend sooner than later to avoid business model risk, making a positive risk by using the opportunity. Case Study 2. Taxi Business and Uber. Purpose of the taxi and Uber case illustrates how due diligence is important when starting a business without thorough research, and what is to come. Too eager to adopt a business model and commit fully can hurt the growth and prospects of the organization. This means an investigation is required to consider the positive and negative risks associated with such business models. consideration and due diligence of the corporation and the associated risks. How do we incorporate research and expected changes to clients' needs to reflect the business model? How do we detect possible risks in the business model? Business case summary. The regular taxi business has been straightforward, answering the need if a person needed a ride from point A to point B. They would just call the taxi office and specify the goal location. The taxi specifies the amount to pay or lets the meter in the vehicle tally the distance and amount. Some taxis can be stopped on the road and told the destination. The taxi driver specifies the amount to be paid, and once at the destination, the customer pays the driver the agreed amount. Here are additional advantages for Uber. A driver can drive their vehicles based on prior arrangement with Uber bookings. Log into your phone app and drop customers at specified locations. Uber driving is not a full-time business. A driver makes money and customer fees are lower. Customers can call from anywhere. This is convenient for the customer. Uber created a business model transformation. The conventional taxi business model has been lucrative everywhere in the United States until recently. Uber Technologies Incorporated, doing business as Uber, introduced taxi service with a new business model. The Uber taxi business model operates differently. The customer can book Uber car service by using an application on the customer's cell phone. The service is relatively safe because of controls built into the application and the services it offers. The driver of the Uber car is checked to make sure they have no security issues. The customer knowing that Uber drivers are relatively safe attracts more customers to use the service. Uber drivers use their vehicles to operate under the Uber business name. The service is attractive and has taken some business from the conventional taxi service. Regular taxi drivers have felt the pinch of losing business to Uber. The effect is that taxi drivers have lost income, Katz March 28, 2018, leading to suicide among some taxi drivers. On March 16, 2018, Nikaner Kaiser, a 65-year-old yellow cab driver, took his own life in his New York Queens home. His family reported he has been worrying about losing revenue. Nikaner paid a great deal of money to obtain his taxi medallion and was not making adequate money to enable him to retire. In February 2018, a similar case happened to taxi driver Douglas Shifter. Douglas shot himself outside City Hall after posting a long statement on Facebook blaming politicians for saturating the streets with taxi cabs that included Uber taxis. The New York Taxi Workers Alliance, a non-profit group that advocates for drivers, reported that 2 other incidents of drivers killing themselves occurred due to financial pressures. Case Study 3. Enron Case Study. Purpose of the Enron case illustrates how financial accountability in an organization is important in leading to growth or collapse of an organization without thorough research and what is to come. Siegel 2018. Not auditing and ensuring accountability may lead to risk problems. This means companies should adopt an appropriate risk standard. Accountability of financial declarations of the corporation to stakeholders and the risks associated. How do we avoid such incidents happening to other corporations? How do we detect such incidents early? Business case summary. In 2001, A.U. Corporation, Enron, based in Houston, Texas, ran into accountability problems with the law due to lies in the organization's merger between Houston Natural Gas and Internorth. Both organizations are small regional companies. Enron employed about 20,000 employees and was named one of the Fortune Innovative Companies for 6 consecutive years. By 2001, It was found that Enron reported financial information that turned out to be institutional, systematic, and creatively planned fraud, later known as the Enron scandal. This led to corporation accounting practices and activities in the United States and subsequently led to the enactment of the Sarbanes-Oxley Act of 2002. This enactment affected the greater business world by causing a dissolution of Arthur Andersen, an accounting firm. Enron eventually filed for bankruptcy in the Southern District of New York in late 2001, using Weil, Gotshal and Manges as its bankruptcy counsel. Enron eventually sold its last remaining business, Prisma Energy International Incorporation, on September 7, 2006, to Ashmore Energy International Ltd., currently called AEI. The idea is to investigate the truth about the claims that enabled them to be innovative 6 times. Was Enron truthful and ethical in their business dealings? The intended audience of the corporation is project stakeholders such as the business owner and senior leadership. Business need: were there risk violations that made Enron look good for nominating 6 times? It is important that similar incidents be analyzed and have immediate resolutions. Goals/scope: a similar incident may likely happen in the short term or over time. It is important corporations and merger organizations identify such occurrences and quickly stop unethical occurrences. Risks/issues: organizations need to check if there are risk areas that include schedule, initial costs, life cycle costs, technical obsolescence, feasibility, reliability of systems, dependencies/interoperability, surety considerations, future procurements, project management, overall project failure, organizational/change management, business, data/information, technology, strategic, security, privacy, project resources, and project lies. Everyone lies, Cuthanet 2016. Lies may cause damage through investigation, and organizations should carry out investigation and ensure accountability. High-level business impact: any damaging operations are likely to create false assumptions that can tarnish the reputation of a corporation. Here are some reputation issues that can damage an organization. Legal issues: loss of reputation, loss of finance/revenue. Employees may lose their jobs, companies may go out of business, loss to investors. Alternatives and analysis: how could this have been avoided? How can we determine a reputable auditing firm for the corporation? How can we confirm that the corporation is conforming to government regulations and policies? Is this too good to be true? Is it statistically verifiable? Is the data collected projected or actual data? Alternative: check this organization frequently for ethical accountability. The budget should be reviewed as a top priority. Who audited the account, and can this person be trusted to do a thorough job consistently? Check if the generation of the budget is too blurred or if the budget is insufficient. If it is insufficient, ask the stakeholders to explain the situation and ask them to revise the budget or change the scope of the project or entities used to conclude the budget. Alternative B: if an unethical finding emerges, legal action will be used against the firm. Preferred solution: financial considerations. Financial accountability should be well detailed. This will include assumptions and supporting documents. What data need to be collected to justify appropriate accountability? Which data points need to be collected and statistically verified? Uncertainties on any of the task area should focus on risk management. This means care and attention should be taken to plan risk management well. Let us spend some time discussing how risk should be managed. Different types of risks. Natural risks. Natural risk can be categorized as earth processes. Typical examples of natural risks are flooding, hurricanes, tornadoes, earthquakes, volcanic eruptions, tsunamis, and other geologic occurrences. Natural disasters can cause death, can damage property, and typically leave some economic damage in its wake. Further causes of severe damage depends on the affected population settings. Infrastructure can be damaged severely. Country-specific risks. Country risks relate to the borders of a country and focus on related financial commitments. Risk may extend to political and economic unrest of the country. Business in a country may experience risk that must be considered. A typical example of country risk is purchasing a bond in countries such as Canada and Mexico. One of those countries may end up defaulting. The assessment will depend on the stability of the countries. One can assume that the default is more likely to happen in Mexico because of the tax systems in the countries. The analysis will depend on the evidence of corruption in the countries, inflation rates, demographics, and education. Other factors may also lead to the prediction of risk. Further analysis will show that Mexico's initial purchase is less than that of Canada. However, purchasing the bond in Mexico will likely cost less. To evaluate country risk, analysts must consider qualitative and quantitative analysis. An effective way to diversify stock is through international investing, but countries in which to invest must be chosen carefully. Deciding to invest in Mexico and Italy is not the same as investing in the United States. The careful analyst will consider the country's economic and political risks that affect its businesses and affects investment losses. Industry-specific risks. Investors may face various risks in industrial silos. Examples are provided in the following. Industry-specific risk can be categorized into different industries such as construction, construction falls, quality controls, and managing construction defects, retail, a product recall, managing crowds, and parking lot safety, and restaurants, kitchen safety, foodborne illness, kitchen staff cuts, and burns. Various industries face specific risks that may occur in another industry or are unique to that industry. Risks may align with daily activities, the equipment being used, or simply the type of business. Retail businesses have different types of risk from restaurant businesses. Further, resources can be used to address and minimize risk, and to promote safety in industries. Analysts should make efforts to minimize workplace accidents or injuries. Also, costs should be controlled appropriately. Some risks can be controlled, such as investing in stocks. Although risky, the risk can be controlled with appropriate care and discipline. Here, thoughtful selection of investment to answer individual goals will keep individual stock and bond risks at an acceptable threshold. Functional area risks. Functional area risks are typically referenced in areas such as division management, facility management, and security. These risks include allocation of building perimeters, chemical storage, elevators, entrances and exits, information security, parking areas, roof openings, shipping and receiving, warehouses, windows, and additional areas. Departmental risks. Numerous risks can affect departments in completing project objectives. We list a few risks: accidental hazards, acts of nature, client-related risk, employee risk, environmental risk, financial risk, fraud/corruption, hostile actions from others, landlord-related risk, legal risk, partner or supplier/contractor risk, political risk, process risk, public opinion risk, and technology risk. Subject matter risk. Subject matter risk is relevant to the following risk areas: country risk, I, political, environment, security, etc. Business risk, I, customer capability to pay, creditworthiness, market factors, etc. Contract risk, I, liability, price, type, penalties, etc. Project risk, I, resources, skill set, methodology, product stability, etc. Technology risk, I, a solution, architecture, hardware and software infrastructure network, delivery channels, etc. Corporate risk is common in corporations. This is a broad range of risk to clients ranging from small business sectors to multinational corporations. Corporate risk requires management that will minimize financial losses. Risk management relates to external threats to a corporation such as fluctuations in the financial market that affect the corporation's financial assets. Here are examples of typical corporate risks. Information technology risk, I. Issues include data integrity, data leakage, loss of intellectual property, or cybercrime. Fraud, I. Employee misconduct may arise in a difficult economic climate. Cost reduction pressure, I. A significant portion of the increase in profits may have to be achieved through cost reductions. Increased competitive pressure in the organization, I. Consumer spending has dropped to new lows. Executives need to innovate products, prioritize customer service, reduce expenses on current offerings, and expand their product portfolio. Compliance, I. Expect more intense scrutiny and regulation of business practices. Liquidity risk, I. Bank credit availability remains limited and companies may need to explore alternative funding sources. Talent risk, I. The market for talented and skilled professionals is flourishing and may lead to retaining and engaging employees as a human resource issue. Political trends, I. Economic discontent or expanding universal geopolitical risk. The high cost of capital, I. Credit crises and a high cost of capital are likely to persist until global credit markets stabilize. Strategic change management, I. A business transformations such as mergers, divestitures, and internal organizations. Startup risks. Every startup business encounters some sort of risk. Typical startup risks range from ideation to ongoing development. Trusting a key employee, relying on cash flow, abandoning the steady paycheck, sacrificing personal capital, estimating popular interest, betting on a crucial deadline, investing personal time, funds, and health. All 7 listed items can create an enormous risk for the startup organization. Security risks. Security issues are everywhere. 2 forces can cause risk. Enemies are getting better and faster at making their threats stick. Companies that still struggle with an overload in urgent security tasks. Here is a collection of IT security risks that need to be noted for organizations to consider. Failure to cover cybersecurity basics. Not understanding what generates corporate cybersecurity risks. Lack of a cybersecurity policy. Confusing compliance with cybersecurity. The human factor plays an important role in how strong, or weak, the organization's information security defenses are. Lower-level employees can weaken security considerations. Organizations must watch the security setup and monitor access levels. Bring your own device policy and the cloud. 1 in 5 organizations suffered a mobile security breach. Funding, talent, and resource constraints can lead to enormous problems in an organization. Little or no information security training for stakeholders. Lack of a recovery plan. Constantly evolving risks. Polymorphic malware risks. Type of malware that constantly changes its identifiable features to evade detection, are harmful and destructive, or intrusive computer software such as a virus, worm, Trojan, or spyware. Risk management process. We describe the risk management overview in detail, including the following processes. Heldman, July 5, 1905. This approach follows the PMI-PMBOK standards. The standard processes are plan risk management, identify risks, perform qualitative risk analysis, perform quantitative risk analysis, plan risk responses, implement risk responses, and monitor risks. The processes are manually based and AI solutions for risk are redefined using an approach applying AI in a generalized fashion. For the generalized risk approach, also see the Risk Management Overview PMBOK 6, PMI 2017. Risk Management Process. Risk Management Process. Purpose. Plan risk management, overall planning of the risk that may occur. This process enables planning risk management activities aiming to increase positive risk and minimize negative risk. Plan risk management defines how risks associated with the project will be identified, analyzed, and managed. In this section, we outline how risk management activities are performed, recorded, and monitored throughout the life cycle of the project and describe, at a high level, the process to be used to record and prioritize risks by the risk manager or risk management team. Identify risks. Determine ways to identify risks. The process documents individual risks and their sources, subsequently helping the project team respond to the identified risks appropriately. Perform qualitative risk analysis. The process of prioritizing individual risks for further analysis or actions on their priorities using the probability of occurrence and impact focused on high-priority risks. This process is repeated over the life of the project. Perform quantitative risk analysis. Numerically analyzing individual risks with other sources of uncertainties combined with overall impact. Literally, it quantifies overall risks exposure on the project. Additionally, it provides quantitative risk information that helps with risk planning responses. It is important that the process is carried out after qualitative analysis is performed. The process is completed through the project life cycle, as needed. Plan risk responses. This process enables developing options, selecting appropriate strategies and actions, and treating individual risks. Responses enable resources to be allocated and document risk details. This process is repeated throughout the project life cycle. Implement risk responses. Developing options and strategies for the identified risk as agreed in the plan. Agreed responses are implemented as planned to address the identified risk. This process is repeated throughout the project life cycle. Monitor risks. Watching for possible signs of risk and taking appropriate action to mitigate or remove it. This process enables the decision to be based on currently identified risks. The Project Risk Management Plan is a high-level plan that details other risk processes. The resources working on the project determine the effort that will be put into taking care of the likelihood of the risk that will occur. The following entities go into project risk management: scope, schedule, and budget are the primary areas of project risk that information going into project risk management must address clearly and well. The collected risk data will be used to analyze the AI system. Tables will be created from the risk management processes that can be used in the AI system. This plan becomes a component of the project management plan, documenting how the remaining risk processes will be performed. Plan risk management with data that can be analyzed using, indicating the structure of each risk process. The process for each risk will be defined in detail. First, let us define what process means here. Developing a processes make up the Process Management Institute project management approach. A process consists of three parts: input, tools and techniques, and output. This approach is adopted in this book. Process icons: initial information required to create process output. This will be provided by other processes or documents created during the overall process. Tools and techniques: tools and techniques are the actions taken to create output. Several tools, methods, or techniques can be used in different processes and provide specific information or operations to achieve the objectives of the process. In general, a tool or technique consists of the following examples. The acronym STAMPED is useful when preparing for certification: S, systems, skills, software; T, templates; A, analysis, audits; M, methods, meetings, including reviews, training, team building, negotiations, bidder conference; P, performance measurements; E, EVM, earned value management, expert judgment; D, decomposition, diagramming. Input is the initial information required to start the process, such as the company's background information, procedures, and requirements before the project starts. The tools and techniques are the experiences, other procedures, and tools required to use the inputs to generate the output. The output varies based on the input, tools and techniques, and requirements of the project. The following icons will be used to denote the requirement. To create a process, appropriate internal documents are inputs from the organization or outside the organization. The inputs are used by the tools and techniques to get one or more output. A general scenario is putting an orange into a blender and getting orange juice at the end. The orange is the input to the blender. The blender is the tool, and the technique is the expertise of the person using the blender to produce the orange juice. The orange juice is the output. Project process diagram. Each process identified in the process table is described in terms of the aforementioned model or methodology. For each input, several sources are provided. They could be previous documents or information obtained in a previous process. For example, the project charter is one of the very first documents created when a project is to be initiated. This document and all its relevant information are used to guide other processes. Also, project process diagram input and output process. For example, in the tools and techniques for define activities, as shown as follows, we described the concept of decomposition, templates, and expert judgment earlier in the chapter. Next, we describe the new item, rolling wave planning. Example: decomposition, rolling wave planning, templates, expert judgment. The output process has two possible effects. The first effect is that the process may create a new document, new information, or new processes. The second is that the output can affect existing processes or documents. We summarize the input and output processes for that area, providing a data flow diagram to demonstrate how the information connects to the project. It is helpful to use the rolling wave planning approach to consider each piece of the project related to risk. Risk management consists of planning, identification, analysis, response planning, response implementation, and monitoring risk on the project. The objectives of project management are to increase the possibilities of positive risk and to decrease the impact of negative risks. Points: case story of Blockbuster and Netflix. Example of business model risk. Blockbuster did not adhere to the new technological trend. Newman, September 23, 2010. AI could have been applied for a solution. The new technology trend builds on social media, and one can watch this approach. Here is a typical trend that needs to be watched: taxi business and Uber. new technological trend, better pricing model, and ease of driver sign-on. Enron Business Burst. Use Enron case study. Use other 3 business cases as applicable as possible. Risk can occur based on lies on the project, as in the case study of Enron. Purpose of accountability of financial declaration of a corporation to stakeholder. That is the heart of artificial intelligence for risk management. If it helped, a quick subscribe keeps more summaries coming. So how do risk and data connect? That is exactly where we started. Go back to the top and watch it click into place.